Hi, my name is Niklas Gunnarsson, and I'm one of the members of the first student group in the Scalable Data Science and Distributed Machine Learning course. Our project is called The Two Cultures, and the aim for our project is to compare and distinguish forum threads from two of the most popular forum sites in Sweden, Familjeliv and Flashback. For this, we will use logistic regression and topic modeling. For the logistic regression, we will use two approaches for the input features, one using only the word occurrences and one using more advanced word-to-vec features. For topic modeling, we will use a LDA model and observe the most significant word in each of the forum. So the other members in the groups are Ahlsén, Martin Andersson, and Styrud. The first part is to find and download the data. For this, we use Språkbanken, which is a research unit for language data. So the first part is to organize the file structure. For this, we use a try and catch approach. So first try to localize a path. And if it's not exist, we get a file not found exception, then we create the folder. So we have one for Familjeliv and one for Flashback. So here we have a script that also do a try and catch approach, trying to download the XML files from Språkbanken. So first we try to see if we have the file already downloaded. Otherwise, we use a batch script, wget. Then we unzip it, and we move it from the driver to the file storage. Two loops, one for the Familjeliv array and one for the Flashback array. Once the data has been downloaded, we want to pre-process it and load it so we can use it for our models. The data is in an XML file, and the structure looks like this. So we have a corpus, which contains of forums. Each forum contains of some thread, and each thread contains of a sentence. And in the sentence, we can find the words. First, here we have some help methods to parse the data. So this first method is reading the XML file and reading based on this schema that we have created. So once we read it in a proper way, we want to reorganize the data so we can use it as we want. And we also have some methods to load and save the data frames so that we can save it to the file storage and read it when we want to use it, so we don't need to do this pre-processing step every time. Just running the functions. It already exists, so we don't need to save it once more. I can show you how the data would look like. I first run the previous notebook. Check all the methods. The schema for the first, the raw XML looks like this. For each forum, we have some ID, some title, a URL, and a thread array, where each thread contains an ID, a title, a URL, and a text array, which contains of some sentence with all the words. So from this structure, it's quite hard to just get the words and the sentences, so you can try to build them for which we will want to build a model. Instead, we can have a look at this pre-processed data frame. The schema is much more flattened. So we have a thread ID, title, and the words, all the words is a string instead. Also collected form ID, form title, which platform is from, and corpus ID. So pre-processed data will instead look like this. For each thread, we collect the thread title and all the words from all the posts in the threads.
Okay, so now we will be looking at a very simple way of doing classification. So we will try to look at a thread and determine whether it's from Familjeliv or if it's from Flashback. And to do this, we will use a method called logistic regression. I do want to warn the sensitive viewers that I will be looking at the sex subforms. So there will be some dirty words and harsh language. First of all, there's just a bunch of imports. I'll run that and then we'll load the data, basically just running the scripts that Niklas presented previously, and then running the functions from there to load, in this case, the sex subforms. So the reason why we chose the sex subforms now is that it's two subforms that should have, at least theoretically, very similar content. Either way, we will find that there's still quite a large difference between these two forms in how the language is used. A lot of the Flashback members are male and a lot of Familjeliv members are female. Next step now is to extract the text columns, and we also want to add a separate column for the labels. Then I make sure that the two forms have exactly the same amount of threads in the data so that we don't overtrain and get biased towards one form over the other. Next step, extract the words. And we use something called a regex tokenizer, and we make sure that we only keep longer words, so words of 5 letters or more. And the reason is that the shorter words are usually just very common words that are not very interesting. It's not going to tell us much. It's just words that are common in the language. The next step is to remove stop words. So basically just, again, a lot of words that don't really have an interesting meaning, just common words. So we're using a bunch that we added ourselves here. And there's also default stop words for the Swedish language that we're using. Run this, and this then is the whole list of stop words. They're going to be removed. Remove them by this command. The next step now is to actually count the words and create a vocabulary, because we don't want to use all of the words. So we filter out basically words that don't occur in at least 5 different threads. We also limit the size of the vocabulary to 1,000 words. We pick the 1,000 most common words across both the forms that fulfill all our requirements. Okay, so here's the actual list of all the 1,000 different words that we are going to use for our classification. So you can see here in the beginning that these words are very, very common words. It's probably very unlikely that we will be able to do anything meaningful with these, but in the end, slightly more colorful language. Now we can go into actually splitting the data. We split it, 80% will be in a training set and 20% will be in a test set. Final step after this is to do the actual training. And here comes the logistic regression model. So basically this is the function that we're trying to fit. In our case, this is just a binary classification problem, so it's quite simple. We are trying to figure out the probability that the label is 1. And we have a function that looks like this. So beta here is the parameters that we are learning. And x is basically a count of the words in the vocabulary. So each word in the vocabulary has its own count. So for example, if word I is hello, and the thread contains 5 instances of this word hello, then x for that word will be 5. I'm running 100 iterations, a very small regularization. It's not needed a lot actually, because we have a lot of data. This elastic net parameter is basically a trade-off between L1 and L2 loss. I'm using 0.5 here, which means it's a perfect average of L1 and L2 loss. Now the training is done, we can look at the coefficients. And we can look at just how the loss progressed. You saw earlier that I ran it for 100 iterations, not really necessary. It's converged basically after 10 or 20 or so. Doesn't go all the way down to 0 because of our regularization. If we made so that it did, it would not really do well on test data. The next step is just really a small analysis here of which words it's actually looking at. So basically the first 5 words here are words that are common for texts from the Familjeliv form. You can see that words are something like husband, childbirth, typical topics for women, I guess, talking about childbirth. And the more common words in the flashback forums are just common swear words. And the Druden and Drudar kind of means chicks, which is just a harsh word of talking about women. So now we can see how well it performs on the actual test data. The C here is the true value, and the prediction column is what our classifier predicts. So it's a lot better than random. It's even hitting it almost all of the time. Also with quite a high confidence, where it's actually wrong. It estimates that it's more or less a 50-50 shot. And if we look at the rock area, it actually goes up to 0.93 almost. And you know, 1.0 is perfect classifier, so we're not that far away, even with this very, very simple method for classification.
We're going to redo the project that we just did, using a slightly different terminology and methodology. So a word embedding maps a word to a vector of real numbers. And we've already seen an example of this when we did frequency analysis, because what you do then is that you map a word in the dictionary to its one-hot encoding. Here we're going to use a different word embedding that's called word-to-vec, which you have to train. And the upside of that model is, among other things, that you can set the output dimension as a parameter. You can set it to whatever you want to. And I refer you to these papers if you want to learn more. And we will use the exact same forums and use logistic regression as well. So I'm going to be quite brief and just skip through the preamble and the methods to load data, because we've already done this. As before, I load saved data frames here into these. The next step is, I'm actually going to do 2 things here. First, I'm going to show you how to get the actual embedding. And then I'm going to show you how you would use that embedding in a classification scenario. So first, to get the embedding, you must define it and you must train it on some data. And this data will be the cleaned forum, the cleaned thread contents. And we'll clean it using the same tokenizer as we did previously. This is how we define our model. So the 200 here, this is included in Spark, so it's just, you just import it and you go. So you set the vector size to 200, that's the output dimension. And we can now train it using any data frame we wish, as long as the input column text contains the thing that we want to train it on. So how do you embed things in it? Well, you take the tokenizer and you simply apply the transform function from the model to it, and then you'll get a new data frame, which I will show you here. You can see that here the result is the vector, the text is the array of words. This is the average of all of the images of all of these individual words. So it doesn't map an entire sentence, it maps a word to a vector. So how would you do classification with it then? Well, then it's actually much easier if you pack it all together in a pipeline. But before we do that, we need to define the logistic regression model. It will be the exact same as we did previously. And then we put it together in the pipeline. We get the training data by simply splitting the data frame that we had. And then we fit the model to the training data. Sorry, and we save it. This also takes some time, so I will use a loaded one, and you can do predictions here. And here it is. It looks quite well, I would say. It looks to get most things right. And if we do a binary classification evaluator on this thing, we'll see that it actually has a very good area under the ROC curve value. It's slightly higher than before, but only just. And well, they seem to be just as good. I also tried to do this with just the titles of the thread rather than the content, but that didn't work well at all. It was basically as good as just guessing flashback all the time.
Okay, so this is the last notebook in our project. And in this one, we're going to try to do some topic modeling. And we're going to do it using LDA, or latent Dirichlet allocation. So, Flashback and Familjeliv are quite different, but they have some similar forums where they discuss, for instance, economy. And each such forum has sub-forums, so topics. So we thought it would be interesting to try to see if LDA can catch this sub-forum structure of both Familjeliv and Flashback, or if it sees some other patterns not really seen in the sub-forum structure. Okay, so first we download the data. This notebook you've seen, 00. There's some pre-processing of the XML files and loading the data. This is notebook 01, which we talked about. So here we've taken some methods and put them all in this function getLDA. So mainly we're using MLlib, the machine learning library, Spark, which has a LDA function. And this getLDA is just a function where we've collected some processing to get everything in the right format to put it into LDA. So it's tokenizing, removing stop words, using a count vectorizer, which you've seen before. And then this is the new thing, so LDA, which has some parameters, which we can set, number of topics, for instance, and how long we train. One kind of important part of this was the stop words. So first we used just a list of stop words we found online. So Peter Dalle has a GitHub account with some Swedish stop words, which we've been using. But then we found that it came up a lot of other words that were really not very interesting when we tried to do topic modeling. So there was some iterative thing going on where we saw uninteresting words, and then we put them in this stop word list. So for actual experiments, which we did, so as I said before, so both Familjeliv and Flashback has economics parts and one part for sex and relationships. So we played around a bit with both of those. So here we'll see the economics part. So we load the economics forum from both Flashback and Familjeliv. The structure of the forums looks like this. So this is Familjeliv. It has 8 sub-forums in the economics part. Flashback looks like this. So some bit difference here, but they're both about the economy at least. And here is where we run the LA function we saw earlier, getLDA. So here we just set the parameters, but importantly, the number of topics that we shows here is the same as the actual sub-forums in both Familjeliv and Flashback. So the results. So what's happening here is just we're preparing things to be plotted or visualized. So I'll just quickly go through this so we see what we get. So this is the topic structure from Flashback. So each color represents a topic, and then the bubbles are the most common words in that topic. So we say Bitcoin, inflation goal, stocks, things like that. This is Familjeliv, so it's a bit different. So I'll talk about children, for instance. So different words, definitely. And here they are side by side. That's the conclusion of our project. So everything we've done is also, we're using mostly libraries in Spark, so everything is scalable. And it's quite easy to play around with everything we've done if you want to experiment yourself.